Assalamualaikum and hi everyone. For today's lesson, we're gonna learn vectors. So this is chapter number 8. So we're gonna discuss these two quantities. We have scalar quantity and vector quantity. So in scalar quantity, we have only magnitude, whereas in vector quantity, we have both the magnitude and also the direction of the value. So this is the difference between vector and scalar. In vector, we have direction, but in scalar, there is no direction. Okay, bear in mind, so the first exercise, we're going to identify whether the given quantity is scalar or vector quantity. If you look at the examples, distance and displacement. So distance obviously scalar because it has no direction. So that means the displacement will fall under vector quantity. Exercise number 1, we have velocity and speed. So speed will be under scalar quantity, and velocity will be under vector quantity because it has direction, whether you're going to the left to the right. Right, now we have force and mass. So mass will fall under scalar because it has no direction. So 5 kilograms, 6 kilograms has no direction, and then force will be under vector quantity because it has direction. Alright, acceleration and volume. Obviously volume has no direction, so your meter cube, your liter will fall under scalar quantity, and your acceleration will fall under vector quantity, whether you're going to the right, to the left, it's because vector must have direction. Alright, now moving on, we have speed and momentum. Again, the speed will be the same in the first question. So we're going to put speed under scalar quantity, and your vector will be the momentum. Right, last but not least, we have the weight and also the work. So the weight will be similar to mass, will fall under scalar quantity, which has no direction, and your work will be categorized into vector quantity. So all of these are very simple. You can just copy and then copy into your books. Now we're gonna learn how to denote a vector. If you look at my diagram, I'm gonna put A and B direction. So the AB will be going to the right. So right now we can represent vector using 4 representation. Alright, the first 2 representation, the A with tilde and AB with an arrow, will be the handwritten version of writing vectors. So if you know write vector in your books, this is how we write it. So we're gonna put A with tilde and also AB with an arrow above it. So this is how we denote vector using handwritten. But if you want to use computer, you can have all the version there. Bear in mind the A tilde, the bold A and the AB bold only for computer version. Alright, because this A bold and AB bold can only be using computer, so you cannot use this version when you write vector, because obviously you cannot make your font bold in comparison with your normal handwriting, because it's not appropriate to do that. So we're going to use only the computer version only for the bold type. So remember, the handwritten version, we must have the tilde. The tilde is compulsory, you have to write it. And the bold version is only for computer version, it's not for handwritten version. Alright, now we have the magnitude of the vector. We can use, if you look at the 2 lines there, the vertical lines called modulus. So the 2 lines there that you see between your vector is called modulus. So it will be like modulus A, modulus AB. So this is to find the magnitude of the vector. Alright, now if you look at the exercise in page 127, we're going to discuss the first example given to you, because there's something about the question that needs to be rectified. Okay, first we want to find the magnitude. If you look at the diagram, you count, okay, 1, 2, 3, 4, 5, 6 boxes, or 6 units going to the right. Alright, now you have 3 units going up, so you have 6 and 3 there. Alright, they forgot to put modulus, because to find the magnitude you must put the modulus. So modulus AD, so will be, you can use Pythagoras theorem to find the hypotenuse. So if you square both of them, so 6 square plus 3 square, So you get 36 plus 9 will be 45. You take the square root and give answer in 4 significant figures. So this is how to find the magnitude of any given vector. Now, exercise number 3, there's only one question there, so I'm going to do it for you. So they give you the original U. So this is the original U, is going up, and then it has one box in horizontal and 2 boxes in vertical. If you look at the diagram there, so it's like that. So that is our original vector. So we're going to draw 2U, so that means it's twice of your U. So you're going to make twice of it. So the direction must be similar. If you look at both the original and A, so the direction will be similar. But if you look at B, negative 2U, so whenever you put a negative, the original vector, the direction of the vector will be reversed. That means the direction will be opposite direction. So if you're going up in original vector, the negative sign will make the vector going down. So this answer will be going down, because direction very important in vector. You must put an arrow going down because it's negative. So the origin is going up, so the negative 2U will be going down. Alright, now look at the C part, to draw 3U. So similar, so we're gonna put 3 times of the original vector, so it's 3 times of the original vector. So you're gonna put you're gonna draw, so 3 times. So remember, the origin is 1, 2, 3. So we're gonna just times 3. So again, 1, 2, and 3. Right, that's how we draw the 3U. So I'm going to give you exercise in page 127, 128, exercise 2 and exercise 4, and I'm going to give you the answers right now. Good luck and all the best to you.